Welcome to the first of two sessions of this tutorial. Actually, last week we had one with for a bit smaller audience, which was concentrating on analytics using Elasticsearch. So that's we're going to cover again next week. But now it's going to be a bit different. So intention is to have it around 45 minutes an hour or so, and there won't be any presentation or anything, so I'll just try to walk you through the basic steps of how to really start with using this analytics platform that we have. So please feel free to stop me at any moment if you have some problem, if you are doing it online while I'm talking, stop me and ask. Yeah, that's all the idea of this. Okay. So basically, what we'll try to cover is this. Where you find documentation about it. Where are the codes to run about cluster, some basic DFS commands, Hadoop commands. How do you get data in? That's going to be really briefly. And what are data that are already imported? We will go roughly just through some parts of it. And what are all the ways how you can work with Hadoop, and then a bit of pig. Yeah? So that's quite a bit to go through. So let us start. Yeah? Next week we're going to go into more details and discuss a bit more advanced things with Elasticsearch. Yeah? But now the basics. So you probably all know this page. If you go to Wiki Atlas Computing, just go to Atlas Analytics, and there is most of information. Yeah. I used my last 2 days to up to date everything here. Yeah. So everything should work, and all the pointers here should be correct. So basically, all the idea of all this analytics business was to get the most important data all at the same place, where one can now do analysis using several different sources and do it relatively efficiently, and not to rely on some people asking them to produce you a plot, and then it takes a month to get it into some kind of dashboard and so on, so that everybody can just go and do what he wants, analyze the way he wants. And there is quite a complex procedure how to get the data in and out and so on, but we won't be really talking here about this developer kind of stuff, how to optimize stuff or any of that. Yeah? So this is going to be on strictly user-oriented. Yeah? So let's go straight to important things. Yeah? So few organizational details. This is the e-group that you can send mails or whatever, asking about details. There is Jira, which is sparsely used, and then important point is Git repository. Yeah? So this is all on GitHub, and there is already, I think, 5 different repositories in it. The main one is Atlas Hadoop, and then there are these sub-projects about network weather service, XAUDs, RTT, PandaLogs. So these are sub-projects. Yeah. Anyhow, you can always just clone this because it's open. But if you want to frequently push things in, let me know your GitHub username, and I'll add you to people or to project or whatever. Yeah. So that's important point. We're going to be using this quite a bit. Yeah. So next things, yeah, about the cluster. Yeah. There are actually now, I think, 4 different Hadoop clusters, and the one we're going to be using the most, and it's the biggest one, is Elix Hadoop. And but all of them can access the same data. The thing is that all of them are accessing data through the network, which is very suboptimal, but for now at least it enables us to see all the data from the same place. There is, in addition to this, there is this AI analytics cluster, which is much smaller and does also all other kinds of things. It can also access the same data. It also has all the Hadoop software on it, but it has additional libraries. If you want something special, you ask me, I add it to this AI analytics cluster, and then you can do things there. To access this cluster, you have to go through Elix Plus, right? Unless you are at CERN. And you have to ask Rainer here. You see this mail. You have to ask him to give you access. But once you get access to a cluster, you don't need any special permission to use Atlas data. So everybody in Atlas has access to our data, and the majority of it is here in /atlas/analytics. So, important things to know. Now, for people who are at CERN, this link will be useful. Yeah? So if you run Hadoop jobs of any kind, doesn't matter is it in Pico or your own code of any kind, here you can see progress and who else is running and so on. Yeah? Now a few more things about cluster. This cluster, even it's rather big. It's rather slow, and there are numerous reasons for that. We won't go into it, but you'll see when we start going for examples, a lot of things take half an hour easily. So it's something to keep in mind. Now, here, just a few words about these other analytics things. Yeah? So, Atlas Analytics Cluster, you can see described here. What these machines are used for, I won't go into that. We can leave it for the next time. Here, pointers to Cloud Lab Analytics, Elasticsearch Cluster. Now, that one is used only for Elasticsearch, nothing else. And now we go to description of data sources. So here is brief list, and every day is getting longer. So we have data from Panda, Panda Service, Rusio, XAOD Monitoring, Dashboard, and Pilot Factory. Yeah? And different people manage different parts of this data. Yeah? So I manage Panda, and that's it from my side. But luckily on the call we have other people who manage Rusio data and people who manage XAOD monitoring data. So if you need more details about specifically this, feel free to ask them. Yeah? So yeah, I also expect these people to update their wiki page here. Yeah? So just keep in mind. So let's start with Panda, because this is going to be probably what most people would like to do an analysis on. There are three things the three main data sources in Panda that we copy to Hadoop. Yeah? One is Panda job status log, one is Panda job archive table, and one is Panda log information. Yeah? First two I do. The third one is done by Saojun. Yeah? And so we'll go first through Panda job status. Yeah? This was requested by Ale, actually. By the way, is he online? No? Okay. So how this one looks like. Yeah. Let me just open one terminal so we can also do things directly. Yeah? So let me just log in. Please feel free to do this while I'm talking. So I logged in to Analytics Plus, and then I'm logging to Hadoop cluster, to Elix Hadoop. Now, what is important to know is to access data or to write there, you have to have valid Kerberos. Yeah? Keep that in mind when, especially if you are writing a cron job, which will be doing something. If it will need Kerberos. Yeah? Okay, so if you checked out a repository, this is Atlas Hadoop one, and let's start with a few HDFS basic commands. Yeah? So how you look where's the data. So I usually do like this: HDFS DFS minus ls, and then Atlas / analytics. I don't know. Can you see what I'm typing? Or font is too small. Hello. Am I talking to myself?
Yes, it's perfect.
I can see.
Okay, great. So this is the how you just list what's in the directory. Yeah? Now, for most of the things here, you can also use a star, but then you have to put things under quotes. So let's go first to look at Panda data. So it's here, and most of commands that you are normally used from shell you can use here. Just you have to prepare this minus, yeah? And some options are a bit different. So let's look at job status data, and let's see their size. Yeah? Minus du minus h, and oops, small typo. So data is organized in directories, yeah? But in your codes, when you say I want this directory, that will include all the data that is in that directory. Yeah? So, and if you are storing something, please store things in big files, because it will be very inefficient if you store anything less than few hundred megabytes. So this is, for example, how you're going to see data in the directories, and you'll see that most of the data that we store in formats where you have a directory with a date. That speeds up quite a lot of things. So each time, for example, I'm importing this data, a new directory is created with a date, and then all the files inside are named in some way, which is not really important how they are named. Yeah? All right. There are a few formats how these files are stored. Often, the most often used are just comma-separated values or Avro. Comma-separated values are not bigger because they are just simply not compressed, and you have to know what columns. It doesn't store which column is what. Yeah? So you have to know to put somewhere on Tricky or somewhere explanation what is what, yeah? Which column is what. Avro files are nicer because they are compressed, so you can process them faster, and they take less space, and they are self-descriptive. So you just open the file and ask what are the columns and what is type of each column. Is it a string or is it a number or whatever? So this table is this data about Panda job status. That's imported from this Oracle table, and it's imported every night by using Scoop. Now we won't go into details what is Scoop, but that's the best way to. Let's just say that that's the best way to get data from Oracle, and it's really fast, like 600 megabytes per second fast. And if you need more details, ask me. So that's the table where it's imported from, and just to describe you what this table is. So each time a Panda job changes the status, it adds one row to the table and saying, okay, this is Panda ID, this is modification time, and when we edit this row, and this is current job status, and what is source label, what is cloud, and what is computing site. So each time a single job changes, it adds a row. So that means that during one job, just one job can add you 10 or 15 even rows in this table. So because of that, this table is ginormous. And in Oracle, we keep only last 1 month of it, but every day is 10 million rows. So processing it is basically impossible. The only really way to process it is using Hadoop, especially because data is spread. All these Panda jobs are mixed and so on. So you cannot really process it in Oracle. It's for nothing in Oracle. And so what one could use this data for is to analyze, to see how much time jobs are spending in what state. And then, so for example, how much time it was in waiting, or how much was signed, or so on. And then you want to slice it and dice it, how it changes with time, how it changes from different cloud to cloud, how it differs from site to site, or depending on job type, and so on. So quite a lot of things can be learned from here. It's just that nobody up to now had really time to go and understand all the possible ways how Panda job can change from state to state. I started that work, but then didn't have time. Anyhow, I wrote most of the code for that, and we'll go a bit later about it. So we'll come back to that code because it is a bit more complex. But first, let me tell you about the most important table we have here, and that is Panda Job Archive table. So basically, it contains all the data about job, or almost all the data about job that we have, and it's ginormous. Again, it has currently, I think, 108 columns for each job, and it's copied again from thing is, it gets copied from production Oracle database into, let's say, spare Oracle database, but that's done not immediately when jobs is done, but after 3 days, and there is a good reason for this 3-day delay, because you want to be sure that the job finished before moving it to Oracle. And anyhow, data from there gets copied with this delay of 3 days into this directory. So again, it's done to Avro files, and let us see just how much data that is. So that's table jobs. And here we imported everything from January of 2015, 1st January. We could easily import more, but unless you need it, we won't do it. Yeah. So if you need it, let me know, and I'll import it. In a day, I can import all year. So you see this data. So last day was 31st of October, and it's roughly, it's actually probably an average 1.1 gigabyte per day, yeah, of data, and you have it, yeah, for all the year. Now there are two club fields which are dropped, but I never found anything important in them. So if you need, let me know. So yeah, recently. This column, there was 10 columns added, which tell you what was memory profile of the job, like RSS, VMM, and all kind of stuff. So that is something that it was really recently added. Nobody was looking at it. Somebody should look at it, yeah? And then see how different machines are behaving, or recognize jobs which fail because of using too much memory and so on. Anyhow, that's, if somebody has time to analyze, that's one thing that should be done there. Yeah? So there are already some analysis done on this, yeah? And here I list them. So one is overflow analysis. That's what I'm doing for my Fox tanks. Analysis of overflow flows. Now this one was rather important, which was influence of all the pledged resources on wait time of US user jobs. Because for a very long time we didn't have this information, and then when Hadoop came, we were able to do it, but now it's getting obsolete because it all exists in Elasticsearch, and it's much nicer and faster to get it from there. Still, I keep code here, so just use it as a kind of example how to do things in Hadoop. And then there is this task duration analysis, yeah, which is rather important. I think Federica should be looking at that. Yeah. So that one, I started writing a Google Doc about it. Let me just show you. You have a link here, which explains basically all the steps in order how to do things. So please feel free to use this as support material for this tutorial. Yeah? So it tells everything about data, about pig, explains data, explains every command line by line. Yeah? So please feel free to look at this and contribute. Yeah? Now, we'll look at some simple analysis that how it's done on Panda data, on Panda archive job data. So as I said, directory where the code is.
Sorry to interrupt.
Yes.
Just a very simple comment, but in the document that you have there, you have permission to edit. Maybe you would like to give permission just to read. I don't know. I mean, just in case.
I actually expect people to contribute.
Okay, sorry.
So let's go and see in this Git repository and see some very. There is a directory called Simple Examples. Let's go first with that one. Yeah? And yeah, a few words about pig. Yeah? There are a few different ways how you can do analysis on Hadoop data. One is you can write Java code, yeah? Which will be the most CPU efficient way. Yeah? But probably most of the people don't know, or don't want to know, or don't have time to spend writing long Java code. The other thing you could do is use pig. Now pig is completely different kind of language. Yeah? What it does is basically it wraps MapReduce code into a new kind of new language, the syntax, and makes it relatively fast to develop. Yeah? problem is that it's not really made for just average user. Yes? It's not really user friendly. Let's put it that way. Yeah? And it's still in development. So when it works really nice. But to get your code up and running, it can be really annoying experience because there are all kinds of perks in it. Now let us just see how one of these look like. Yeah? So let me go to the directory. Big codes, simple examples. Let's see once, just calculating. What is it? So
Ilya, while you're
this
doing
code,
that, sorry, is that code on GitHub or is that
yes,
just in your
this
program?
code is on GitHub. If you check it out, if you cloned it, you can just look at your computer there. So these simple examples I've tried to put a lot of comments into them, so just to have Pig you can run either interactively or you can run it just as a script. Now, if you just start it like this, you're gonna get all kind of log information, and that tends to be too much. Yeah. So that's why in most of these codes I put this log4j properties file, and if you just start Pig using pig -4 log4j properties, then most of these info and warning log messages will disappear. So now we had this started, and let's go through this script line by line. So what this code does is it just calculates what's the number of input files, what's the size of input files, and groups and prints that out for every user. So just to see how much input data each user used. Very, very simple, the simplest example here. Yeah. So we start by here, because if you run code multiple times and each time you produce a result, it won't be automatically overwritten. So you have to remove it by yourself. So that's what I'm doing here. So this line removes any previous result, and it's just like RM force. Keep in mind, this data that you produce ends up in your HDFS home, let's call it home directory. So it doesn't end up in /atlas/analytics, but in your home directory. Okay. So and then we'll load two libraries that we need. Piggy Bank is the one which you basically always need. It uses it gives you even the simple like average and functions like that. Yeah? And the second one will make you able to load other files. Yeah? So a few more things about Pig. Yeah? Pig or Pig Latin, how they call it properly, is a language which just describes data flow. Yeah? So you will never ever see loops and stuff like that in it. Yeah? And a set of commands is rather limited. So sometimes, if you need something more fancy, you have to write your own function, and we'll see how you do that. And you can do that in Python or in Java, but we'll come to that. Yeah? Then this one will will use to store output data in CSV files. And that is nice because so when you produce the results, you can either copy paste it directly from your screen if it's some small results, which often it is, or you write it into CSV files and then load it into Excel or R or Root, whatever you want. Yeah? But Excel is quite easy way. Let's put it this way. Yeah? Now, here, this is how you load the data. So what I'm doing here is I'm loading 10 days of May of this year, and it's as simple as that. But you'll notice that if you start just typing it, you'll start noticing quirks of big. For example, it won't work if you don't put space here in between variable name and equal, and you have to have also space here. And then different commands require to have everything in capital, and some commands don't. Yeah? So some are case sensitive, some not. Yeah? So that's again very crazy quirk. So all idea is that you have your command on the right side, and you just assign it to a variable on the left side, and that's basically all of it. Now let's see what are all the variables in this. So we will do describe. And this is it. Yeah? So for this example, we'll need Panda ID. We'll need prod username. So that's this one. We'll need number of input files, and we'll need number of input data files. I don't remember which one is it. And then we'll need size. That's it for this example. So for each one of them, you see what's its type. Yeah? So Panda ID is obviously long, but everything which it doesn't recognize is either is character array. Yeah? So you'll see quite a lot of these character array ones. And then what we're going to do is we will select only user jobs, so no production jobs. And that you do this by selecting prod source label to be equal user. Now, this is filter command. There is not many commands in Pig. Yeah? Basically, there are commands to load, to filter, for each, and to group. And that's basically like 4 commands. Now, what happens here is you've seen that I got my command prompt back quite quickly. It didn't do anything. Basically, only commands like dump, which print out on the screen, or store, will actually start execution of the code. Yeah? Everything else doesn't do anything really at that moment. Yeah? It doesn't process any data. So let's now. So now we filtered only user jobs, and we will print out first 10 lines. Yeah? And this is how you do it. So because you don't want to print now 10 million lines on your screen, you select 10 lines, which will be randomly selected 10 lines from this data, and you dump it. And so basically we are now asking just print me 10 lines, and now we'll see how much time it's going to take. Yes? So now this is, because this is dump command, now this is really looking for the data and executing. And I can tell you it can take quite a bit of time, even just to dump 10 lines.
Could I ask a question then?
Yes.
While we're waiting?
Yes.
So, I mean, in this example, you obviously knew that the prod source label you were looking for was user. is there a way, is there a command that you can basically do, say, list all the prod source labels that they are and tell me how many of each there are? Is that a command that's easy to do? Because, I mean, in general, I'm guessing if we look at these things that we might not know, obviously, I mean, it could have been user, it could have been pilot, it could, it could be prod or it could be production, things like that if we're searching. So it's not, how do we know what's going to be inside a category?
Exactly. Very good question. So there is no easy command to do it in Pig. But we will come very soon to it. What you do is you want to group all the rows based on that variable, on prod source label, and then print, for example, that source label and, for example, count how many rows, or sum of some other variable where it's grouped per that prod source label. It will come very soon to it. So this is, for example, here. Okay, until this comes back, we can go further. So here we will select only the few variables we will be really interested in. Now based on previous filter. So we don't start from the scratch, but from this previous filter, we will generate start time, creation time, and input data files, input file bytes, and prod username. So these are really just the ones we want. Now, what we first want to do is we want to calculate average number of input data files and their size, average size. And this is how you do it. So while you don't do for loops, there is this for each. So what you do here? Now let me explain this line. It's rather quick. So you group all the entries here of this filtered out data, and then you for that one group you generate these new two variables. One is files and one is files, where file is average of number of input files, and the other one is average of input file bytes, and I convert it to megabytes. And then I just print this result. So this will now give you for all the rows that we had. Now that it's already some bit more serious calculation. But now this other question, how do we do, for example, per prod username or per prod source label? It's exactly the same thing. So you would group the data by that variable, and then for each element in that group, you generate what was that group. This group will contain this prod source name and these averages. And now instead of getting two numbers, so this would give you two numbers. One is average number of input data files, and this is average size of input files for all the data for these 10 days, while this one will give you for each prod username these two variables. And that's basically it. We then dump it on screen and we store it in a CSV file. So if you want to import it into Excel, it's easy. But so if you would want to see what are all the things in prod source label, you would do grouping by prod source label, and then for each group you would just generate group and nothing else, for example. That would print you only all the prod source labels. Or you could say group, comma, count F2 prod source label. And then it would give you also a number of times each of them appears. Does that answer your question?
So, sorry, the prod source label in your example here are the Panda ID, pilot ID, creation time.
No, prod source label is just a variable which tells you is it a managed job or user job or
Right.
test job. I think
Okay.
these are the options. Now you see that I don't know if other people are doing the same thing. So we overwhelmed the cluster, but I still didn't get result. I didn't get my 10 lines of data. Usually it's not this slow. It's this slow, but it's not this slow. Usually you wait, I don't know, a few minutes to get the 10 lines of data.
Okay, this makes it a bit of a pain to develop, isn't it?
Yeah, this is quite a bit of pain to develop. Yeah. And we hope that they're going to fix the cluster.
Yeah,
But
yeah, I know
okay,
that there
yeah,
are.
we got it. So this is how it looks. And so now I'll run the rest of the lines. So we printed 10 lines. Now we're gonna select few variables. Now you see again it does nothing yet. And then we calculate these averages for all of the data. And then we wait for a little bit. So this is really example. Whatever you do in Elasticsearch, do in Elasticsearch, because in Elasticsearch this would take 10 seconds. Okay, until this comes.
That's because most of the work is already done.
I think it's mostly because it's a good cluster.
Ah, it's a better cluster, okay.
Yeah, I mean, while it's much smaller, so
Yeah.
it has only 6 machines, while this Alex Hadoop has 20-something. It has storage directly in each machine, and machines have much more memory, and these are not VMs and so on. So there are quite some advantages of that one. So this would take 10 seconds or less. But let's now, until this comes back, let's go further and see the other example. So now this is jobs per user per cloud. Now you'll see, like, everything repeats up to here. So here I filter out all the users which have prod username Ganga Robot, which is basically all Hammer Cloud jobs. And that's something that you should really always do, because they take even sometimes 15% of all jobs, which is ridiculously too much. Now, so I clean these jobs out and use only these 3 variables: prod username, Panda ID, and cloud. And then now, this is more interesting, because now I group not by 1 variable but by 2. Prod username and cloud. And what I'm going to be printing out is these 2 variables. That is what this group command represents, and how many of them in each. So what will get printed out here is for each prod username and cloud, for each combination of these 2, it will print out how many jobs. So that's a slightly more complicated example. But you can put here as many variables as you want. It's just that your output is going to be bigger. But this is how you slice the data. Okay. So these are 2 really simple examples. now we'll go for something a bit more complicated. So here are more realistic ones. Let's go and see, for example, US user priorities. So this one is basically trying to answer a question: do US users have higher priority, or do their jobs actually end up quicker just because we have some extra resources in US? That's basically it. And we look at it at few variables. So what we do differently here? So up to here, everything is the same. We again filter in only user jobs and filter out HANA Cloud. Now this is how would you would do something more complex, like, okay, let's look at only new data, yeah, not 2012. And now you'll see something special about this one here. So when for each row here, what I do, I run this function which derives for me duration and CPU efficiency. Because we don't have stored CPU efficiency, I have to calculate. So, and this function accepts creation time, start time, end time, and CPU consumption time. So basically, what you do is you calculate what was wall time by subtracting start time from end time, and then you calculate CPU efficiency, which is CPU consumption time divided by that thing that you calculated. And just for some other reason, I calculated also queue time. Yeah? So that is time that job was waiting in a queue, which is you subtract start time from creation time. Yeah? And so that's how you add a few more variables. Yeah? And function to do that is here. Now, and that function, or all that file, is loaded here. Now you'll see this code is Uton, or I'm not sure even how they pronounce it. It's Python-like. So let's see how that works. Yeah? So basically here you define functions. The only and they look quite normal in the sense of Python normal. The difference is that at the beginning they have defined what's the output schema, and that's basically the difference. So you have to learn a few things about how different types in Pig map to Python types, but it's not too complicated. So here I basically say this function will return tuple of wall time, CPU efficiency, and queue time, which will two of these will be ints and one will be full. So these are input parameters, and the rest is standard kind of Python. Yeah? So it's nothing really fancy. And this is how you register it, and then this is how you use it. And then it gets executed for each row. So now we have these new variables added. And what we do here is we just check what's the number of jobs per cloud. And then we split these two in jobs which were running in US Cloud and jobs which were not running in US Cloud. This is how you match strings. Yeah? Important to know. And then what I do here, I group jobs according to where a user comes from, which is strangely named country group. and then I just generate how many jobs of different user countries come in each group, and then the rest is rather similar. So basically, then you store it and then load it into Elasticsearch or whatever. Sorry, into Excel or whatever you prefer, and see the results. So this example you should use just to see how these user-defined functions work. So it looks clean. Code looks rather clean. Yeah, if you look at it. Problem is that to develop it, it's rather tricky. Yeah? So that's second example. Now let's see something. I don't know how much time people have. We are already at 10 o'clock. Are people okay with continuing for 15 more minutes, or?
Yeah, if for me it's fine. If you have divided
Yeah.
like this.
For me, it's fine.
Okay. So we'll continue. I'll try to speed up things a little bit, but it's rather longer. Okay. This is. Let's see now. Task durations. How, for example, would you look for that? Now this one I'll show you also analysis code, which I did. So this is basically, again, you load the same kind of data and you extract do few operations, but then here feel free to use this code as an example. So how I load it in and show it in R. I don't know if anybody is using R from you, but it's rather convenient way of making plots, and it's rather easy to read results from CSV and files, and you just give it a column names, and that's basically it. The rest is standard R. So that's one example. And let's see one with. Let's see. So this one is a bit more involved. So this one not only calculates some things, but also reads them back and sends them to Elasticsearch. Yeah? So let me just show you how this sender looks like. So reading from Hadoop using Python is not really nicely done. So you have basically to run it run it as a command, yeah? Where you list files and you basically cut file to get to its data. So just so you know, yeah. Then so there is few more examples here. For example, what you could do. That's something that I wanted to do but never found the time. You could try to find out a number or weight for each CPU which is used in Atlas by just looking at CPU time spent by different jobs, but jobs which belong to a larger tasks, which are by definition split to different places or different CPUs. So then from each task you find out some weight for all the CPUs which were run on that task, because you assume that these jobs are the same. Yeah? So that's something that somebody should look at, and then we would get realistic numbers. We wouldn't have to rely on COCAP and so on. Okay, so let's go back from Panda. Let's go to XAOD data. Yeah. So this is in a different Git repository, and what this does is the following. Yeah? So that's also well described here. Let's go here. So data is basically described here, and then there is a link to Git repository, then there is document explaining it. But let me just show you what this does. Yeah? So first we have this parser code. Now this is Java, yeah? And it's not really complicated. It's what it does, because the original data is JSON. That's how we store it. You cannot really do Python straight on it. Yeah? You cannot do pig on it. Yeah? So what this code does is takes this JSON, loads it, and returns in a format that just variables, and that's all it does. Yeah? But here you can use it as an example. If you need to do stuff like that, and you want to do Java, this is the way to do it. And then you just have to use Maven to get a jar file, which you call directly from your pig code. And this is how a code looks like. Yeah? So for example, this code will give you task per file format. So how popular are different time formats, file formats. So that's roughly how it's done. Yeah? There is much more examples here. But when you make a code, please put it in repository so that other people can look at it. Yeah? And the simple R code to plot few variables from here. Yeah? All right. I have a feeling that I bored you quite enough for today. Maybe we just try to answer a few questions if people have some questions, and then we continue next week. Any questions?
Yeah, one of the questions I had was, are all these languages equivalent?
Sorry?
So are all these languages equivalent? So if I use pig or Python, the result is equivalent. It's not that I have
you cannot really use Python. You use Python just to write functions which you don't have in pig. Or you can use Java to write these functions, but you do use pig to process the data.
It's always pig to process.
Yeah,
okay.
Pig is the thing that splits this job on these 20 machines and collects the results and sends it back.
Yeah. Okay. Any other question? No. So, are you going to give the second part next week then, Ilya?
Yes.
Yes.
If there are people interested.
Yeah.